For 8.6 day 2, we are going to expand on our common log knowledge, and we're actually going to use common logs, which remember are logs with the base 10. Okay, that just is written as log. You don't have to put the 10. You can if you want to, if that makes more sense to you. But we are going to use them to solve. So the times where you use them to solve is when things like number 1 can't happen. So let's refresh our memory on ones like number 1. For this one, we have 2 to the 4x equals 32 to the x minus 1. Now, what we always did was we tried to get them the same base. And I know I can rewrite 32 as base 2. That would become 2 to the 5th. So once they have the same base, you are actually able to drop the base and then solve, right? Don't forget to distribute. So we have 4x equals 5x minus 1. So negative x equals negative 1, which means x equals positive 1. Okay, and the steps are off to the right. Rewrite both sides with the same base. Equate the exponents, aka drop the base. And then solve as we normally would. But then you get into ones like this. Okay, clearly it's a little bit more complicated, and maybe we would be able to get the same base, but we have to get the base 5 by itself first. So I would subtract 6, and we get 44. And then we need to get rid of the 2 by dividing by it. So we have 5 to the x plus 2 equals 22. So now normally this is what it looks like and we would get the same base, but clearly I cannot write 22 with base 5. So we are going to then go to step number 2. Okay, we're going to take the log of both sides. So I always just write log here and here. So now we have log of a base, well, this is base 10, okay, of 5 to a power. And remember, anytime you have a power, you can throw it out in front. Okay, and this is what we're going to do every time. So we have that x plus 2 and then log 5 equals log 22. So now instead of distributing log 5 in, because that makes it way more complicated, right? Remember, log 5 is a value, so I can get rid of it by dividing by it. So now we have x plus 2 equals log 22 over log 5. And all you would do is then subtract 2. And that's going to be what x equals. Okay, now I would do these in pieces. Okay, otherwise you have to be very careful on how you type them in. So I would do log 22, hit enter, divided by log 5, hit enter, and then subtract 2. So we get negative 0.0794. Okay, they do say 10,000, which typically is what they're going to ask for. Okay, now let me show you this on your calculator. Again, you have your log button. So what I would do is log 22. You could do log 22, close your parentheses, log 5, then close your parentheses, and then I would subtract 2 after hitting enter. If you do it all at once, you are risking that your calculator is going to do something weird. So I would do step by step. So we are going to solve by rewriting the log again. Okay, so we are going to do this. We didn't do inequalities here, so let's just treat this as an equals. So don't worry about this extra step. Okay, so again, we are going to log both sides because the exponent is by itself. And anytime we do that, we throw the exponent out in front. So we have y log 5 equals log 42. And the only thing to do is get rid of log 5. Now, oftentimes I see students trying to get rid of log by itself or the 5 by itself. You have to remember that log 5 is a value. So it all is tacked together. Okay, so you can't, it's kind of like if we have 2x plus y equals 10, right? If you want to get y by itself, you don't divide by 2 and then subtract x, right? We would take the 2 and the x at the same time by subtracting it, okay, or dividing it if they were being multiplied. Okay, so it's the same deal here. They are attached, okay? So all we have to do is type that into our calculator, and we end up getting y equals, let me do it really quick, log 42 divided by log 5, and we get 2.3223. All right, so then we have word problems. Okay, these are typically done the same way as you've seen in the past, but this time we're going to solve for something different. So it says, what is the number of years? So we're trying to solve for t in our formula. That you invested your money in an account if you have $29.50, but you deposited $2,500, and it pays 4.5% compounded quarterly. Okay, so this was our A equals P, and then 1 plus R over N to the T. So we need to plug in values. So A is what you have now. So it's going to be $29.50 equals what you deposited, which is $2,500. From there, we're going to have 1 plus, and our rate we know is 4.5. So we need to change that by moving it 2 to the left to 0.045. And it's compounded quarterly. Remember, quarterly means 4. So we need 4 up here, but now we need t as well. We don't know what t is. So we're going to try to solve for t. The way that I would do this is to get rid of the 2,500, and at the same time, I am also going to clean up this inside because I can get a value for that. So 2950 divided by 2,500 gives me 1.18. If you add 0.045 divided by 4, and 1, you get 1.01125, and it's raised to the 4t. So now we're in a similar situation that what we've been in this whole time. We have something raised to a power, and we want to figure out what that power is. We don't know, we can't get them to be the same base, so we are going to log both sides. When we do that, we could throw the 4t in front. So I'm going to rewrite it over here. We have log of 1.18 equals 4t times log of 1.01125. Now, in order to solve for t, you have to divide, and you can actually divide the 4 and the log of 1.01125 at the same time. Otherwise, you can do them separately. That is up to you. You get the same answer. So if you type it in your calculator correctly, log of 1.18 divided by 4 times log 1.01125, you would get 3.6987. Now, it doesn't really make sense to do 3.6987 years, so I'm okay if you round up or down. You do need to give me a solid number, so I would definitely say round up here. So you would say 4 years. Take you 4 years to get there. So we're just going to have some more examples of solving by taking the logs. Feel free to pause the video and try these out before you watch me do it. So for number 5, what we would do is just log both sides. And that means I throw the x out in front. So we have x log 6 equals log of 40. And all you have to do is divide by log 6 on both sides. So if you type it in your calculator, log 40 divided by log of 6, you get x to be 2.0588. On number 6, I need to isolate my base first, right? So in order to do that, I need to subtract 3. So we have 4 times 2.1 to the a plus 2 equals 5.25. Then we're going to divide both sides by 4. 2.1 to the a plus 2 equals 5.25 divided by 4, which is 1.3125. Now notice how I haven't rounded those decimals at all. If they give you 4 or 5 decimals and it stops, use all of it so you're not rounding multiple times. So at this point, we're going to log both sides, which means we're going to throw that a plus 2 in front. And at this point, I want to get a plus 2 by itself, so I would divide by log of 2.1. But then obviously I am going to have to subtract 2 as well. So our final answer would be the log of 1.3125 divided by log of 2.1 minus 2. And you end up getting negative 1.6335. Number 7 is done almost the exact same way. We're going to add 1. And then we will end up dividing by negative 2. So we get 3 to the x equals negative 6. Now we would log both sides and throw the x out in front. I'm going to write this up here. We have x log of 3 equals log of negative 6. And then we would divide by log of 3. If we type it in, log of negative 6 gives me an error, right? Which hopefully we find out why, or we think about why, right? Log of a negative domain does give us an error. We can't have a log of a negative. So that means that we have no solution here. All right, so feel free to try these last 6 out. I'm going to post the answers on here in just a second, and then you can check your work as you go. So on number 8, you had to combine the logs first. So you would have x times x minus 3. And then you would have to exponentiate both sides by doing base 10. So you have x times x minus 3 equals 10, which then you can factor. When you factor it using the t-chart, you would get 5 and negative 2, which negative 2 would not work because you would end up getting a negative in the log. Number 9, you have to subtract 6 and then you log both sides. From there, we throw the negative 12 out in front. And then you can divide by negative 12 and log base 10 at the same time if you would like. Number 10, you needed to make the 4 an exponent. And then you would exponentiate both sides. Number 11, you needed to add 5, and then you can exponentiate both sides. When you do that, log base 6 cancels, and you're left with x squared equals, and this is a giant number, this would be 60,466,176. Take the square root, you get 7,776. Number 12 was really tricky, and you had multiple routes that you could have went with this. Your final answer should be 2. So what happened here is it was subtraction, which means that it's actually division, right? So I rewrote it with division. Now, what happened in the next step is I just cross multiplied, and that's how I got this one right here. From there, you would recognize that you need to factor. This is difference of squares. You can only take the positive because of the negative not working when you plug it in. And number 13, you might have been in the habit of taking logs of both sides. If you were, you still could have gotten to the same answer of negative 3 over 7, but you can get the same base, so you should have, it is much easier in this case.